All right. Waiting to see things starting. I'm online. Okay, looks like Twitch is going, and there is YouTube. Good morning, everybody, or afternoon, or wherever it is, wherever you are. We are jumping back in to this paper, which is called, I definitely don't remember the whole title, Multitask Deep Neural Networks for Natural Language Understanding, by Xiaodong Liu, Pengcheng He, Weizhu Chen, and Jiangfeng Gao of Microsoft Research and Microsoft Dynamics 365 AI. I don't know what the difference is. Hello, Necroduke. Thanks for joining. So in the past 2 weeks, we read through all of the sort of like model specifications, talking about the way that each task was set up and the scoring for each task. And the big difference between this particular model and other types of models is, so up to here, it's just the same as BERT, and actually they are using the BERT pre-trained model. But what they're doing is they're shuffling between 4 different types of tasks, and within each type of task, we have several tasks that fulfill that type of task, except for pairwise text similarity and pairwise ranking, that each only have 1 task. And then we're using performance on each of these tasks to update the whole model. So that's what makes it multitask as opposed to transfer learning. In transfer learning, you have your pre-trained model, and then you're adding a couple layers on top of it, but those layers don't update the pre-trained model. And in this case, we are actually updating the pre-trained model as well, is my understanding of the difference. And we read all about the algorithm design. We read about all of the different data sets that they're going to go through. Here's a little summary of the different data sets. And as you can see, there's quite a few of them. Most of them are from the GLUE dataset, which is the same one that GPT-2 and the BERT model were trained on. And then we have 2 new ones, SNLI, well, new for this particular task, and Scytale. SNLI is the Stanford Natural Language Inference dataset, which is used for entailment labeling. That's logical entailment. And then Scytale, which is another entailment data set, but it comes from science questions. So I believe it comes from I want to say 3rd grade science textbooks, maybe? I sort of vaguely remember that there is a data set like that, and I think it's this one. No, I don't think that is that one, because I heard about that data set in 2016, which was before this one was released. So forget what I said about 3rd grade science textbooks. Ignore that part. Sorry, a little bit of tea. And they are only using that for domain adaptation. So both SNLI and Scytale aren't actually used for multitask learning. So they are never used to update the whole model. They're only used to create sort of a new layer with task-specific weights, just like in BERT, which we read together, if you want to go back and watch those videos. Okay, implementation details. So their implementation is based on the PyTorch implementation of BERT. We use AdaMax as our optimizer with learning rate of 0.00005 and a batch size of 32. The maximum number of epochs was set to 5, and remember that in each epoch, we shuffle through all of the different tasks. So an epoch will do updating for each of those tasks. Necroduke says, I think I need to go back and watch those videos. Yeah, me too. It would be helpful to have a refresher, because all of this work is building on each other. We're just sort of unintentionally, because it's what's interesting right now, building kind of a literature review. This is what I would do if I were writing a paper on language modeling, is go through and read all these papers. A linear learning rate decay schedule with warm-up over 0.1 was used unless stated otherwise. Okay, so as the model is learning, the learning rate decreases linearly. Warm-up over 0.1, I don't necessarily know what that means. The answer to life says, isn't that learning rate schedule just GNOME? I don't know. Maybe. Yeah. Let's see. GNOME, let's say linear learning rate decay schedule. Let's do a little, and then GNOME is what the answer to life is suggesting. I'm so confused. Oh, Negative says 5 to the negative fifth is actually 0.336. Oh, interesting. I thought that was scientific notation. I guess that's actually a natural log, maybe? The answer to life says warm-up is normally a linear increase in learning rate for n steps, then decay after. Oh, I see. So it's sort of like you have a little bit of an increase to get to your area faster, and then it decreases under the assumption that as your model learns, it'll sort of zero in on the minima that you want. But if you keep your learning rate very high, God, I wish I had a whiteboard. If you keep your learning rate very high, you will, you won't be able to get to the bottom of your minima. Is that focusing? I got to do the beauty thing that people do. You'll sort of like overshoot the minima because you can't take tiny enough steps to get to the bottom. Nakaduke says, 0.0336. Ryan says, warm-up is starting the learning rate lower and then slowly raising it on the first epochs who totally bro out the pre-trained model's weights. Oh, I see. So it's something you do with a pre-trained model. Interesting. This is very helpful. Not something I've run across before. All right. Following Liu et al. 2018, so one of the author's earlier papers, we set the number of steps to 5 with a dropout rate of 0.1. To avoid the exploding gradient problem, we clipped the gradient norm within 1. All the texts were tokenized using word pieces, which I think is the same as what Bert used, and then were chopped to spans no longer than 512 tokens. Okay, so this is just a lot of the technical implementation details, and then a link to the BERT model that they used. A little sip of tea. Sorry, I've been sick, so I'm trying to stay hydrated. I was at an offsite, and somebody at the offsite was a typhoid Mary, and we all got home and we're like, "Are you sick? I'm sick. Are you sick? I'm sick." I think like 10% of the Kaggle team is just sniffly right now. All right, so these are the results. We haven't gotten there yet. Glue results. The test results on Glue are presented in Table 2. MTDNN outperforms all existing task systems on all tasks except WNLI. It's that Winograd corpus that people get so salty about. Creating new state-of-the-art results on 8 Glue tasks and pushing the benchmark to 82.2, which amounts to 1.8% absolution improvement, I think that's supposed to be absolute, over BERT large. Since MTDNN uses BERT large for its shared layers, the gain is solely attributed to the use of MTL and fine-tuning. MTL is particularly useful for the tasks with little in-domain training data. As we observe in the table, on the same type of tasks, the improvements over BERT are much more substantial for the tasks with less in-domain training data, e.g. the 2 NLI tasks, RTE versus MNLI, and the 2 paraphrase tasks, MRPC versus QQP. Okay, So let's break that down a little bit. So they got better results than everybody else. They're suggesting that because they're using the same model and the same architecture, the difference has to be due to this multitask learning. It's useful. It's especially useful when you don't have a lot of in-domain training data. On the same type of tasks, improvements over BERT are much more substantial for the tasks with less in-domain training data. So they're saying they're doing better than BERT because they can handle very small amounts of in-domain training data due to the multitask learning, is their claim. And this is particularly clear on the natural language inference and paraphrase tasks. Okay. The Answer to Life says, I tried to run BERT large once. Rip that computer. Oh no. Excuse me. I'm trying not to sniff on the mic, but also if I mute the mic, then it unsyncs the audio and the video, and I don't know about you guys, but that drives me nuts. So I'll try to warn you if I'm gonna sniff so you guys can mute your computer. Okay, let's go look at these results. And I'm just expecting them to be like, our numbers were bigger. Look, their numbers are bigger. That's exactly what they suggested. Except for... okay, so this is a little bit... I would like to see them. So here it's like clearly bigger, clearly bigger, clearly bigger, clearly bigger. This is the Elmo by LSTM single task pre-trained transformer. I have no idea which pre-trained transformer they're using. I'm guessing this is just like the Vaswani model. GPT, not GPT-2. I believe this paper came out before the GPT-2 paper. BERT large, and then their model. And then you see here there's a couple of ones where they actually have the same score as the BERT large model. So in the MNLI-M dataset, and then here in the Winograd Natural Language Inference Corpus, actually all of these models have the same thingadoogle score, and here they didn't bold that. So I would actually like them to bold things that are also a tie with their model, in addition to just like bolding their model when it is, the highest, but it's highest as a tie. The Answer to Life says, what's AX? That's a good question. I'm not entirely sure. Do they mention it here? They don't. Let's see. Do they say AX anywhere else? The x-axis, not super helpful. Softmax, that's not it. Softmax, that's not it. Adamax? That wouldn't be it. That wouldn't be like the score of the optimized. That's a weird thing to report. Maximum. That's a great question. I don't know. I'm wondering if that's a typo and that's supposed to be like state of the art or in bold. Shared layers from glue. AX. What was after WNLI? Maybe it's like some sort of summing, I guess? None of these could like become AX through a typo easily. I have no idea. For large shared layers, it never shows up again. Yeah, I tried searching for AX in the paper, but it doesn't look like it shows up anywhere else, except as like word parts. Aminov says, I want to say that I learned about this initiative from your Twitter, and all these live streams are an amazing resource for amateurs like me. Oh, thank you. I'm really happy they help. It's a good way for me to stay current too, because things just changes so fast. You got to stay up to date. Yeah, that's a great question. And the Answer to Life says, why isn't it bold even though it's the biggest number? Another great question. It can't be the average accuracy across all tasks because it's lower than any of the other scores. Maybe it's something from Glue. Let's check out the benchmark real quick. Maybe it's something that they, Oh, this is not very reactive. Okay, it's definitely something that they report. It is the Diagnostics main Matthews core. What does that mean? This is not helpful. Oh, wow. Snorkel is way up there. Interesting. Snorkel is a system that combines expert rules with deep learning and does it do reinforcement learning to pick the rules? I'm just really surprised to see it far up there. Yeah. Okay, so AX is Diagnostic Main Matthews Core. I have no idea what that means. Maybe it'll mention in here. Nope. Diagnostics. Download the diagnostics table, blah, blah, blah. Diagnostics table, diagnostic examples, diagnostic data sets. Interesting. So it seems to be some sort of correlation with the main diagnostics. So maybe this is a measure of like overfitting. It looks like the things higher up on the leaderboard also have a higher score, and things lower down on the leaderboard also have a lower score. So I'm guessing you want it to be higher. Maybe it's like correlation with humans, because the human score doesn't have it. I'm gonna zoom out a little bit more. It's still okay. Well, that's helpful. Okay, so it looks like the mouse over there is just like dash. AJ says it might be explained in the original glue paper. Yeah. For now, let's just say that it is something that the glue benchmark reports. And it's not Ryan says Matthew's correlation coefficient has been used in a few Kaggle competitions. I don't have a strong understanding what it is, but figure it's building on that. Let's see. Correlation coefficient. Blah, blah, blah. It's a confusion matrix. So it's sort of a measure of, so it's sort of like F1, looking at false positives and false and true positives and negatives. So probably higher is better. Necrotic says the Matthews correlation coefficient is used in machine learning as a measure of the quality of binary classifications. So I guess it's just like model-wide measure of goodness, and you want it to be higher. Also, it looks like this model is no longer state-of-the-art on Glue, which is not super surprising. That is a fast-moving benchmark, especially since the BERT paper came out. So that is... Oh, so this is on the test set specifically, which are scored by the evaluation server. And then they also report the dev set results. And their model is better, blah, blah, blah. I'm just looking and comparing this to up here, and it does look like they are overfitting for at least the QQP task and the RTE task. Some of them maybe they're not, but it does look like there might be some overfitting here, that they've gotten much better results on the dev set than the test set. So, and this is also reporting the single task deep neural network that uses the same model architecture, but instead of fine-tuning one model for all tasks, we create multiple one for each task using only in-domain for fine-tuning. And what they're showing here is that the single task model does not perform as well as their multitask model. And then they also compare that to BERT base. So it looks like single task tuning is better than BERT base, and then multitask learning is better than single task learning or BERT base, is the point of that table. The answer to life says, so why isn't it bold? I'm guessing it's not bold because they made a mistake. This looks like a table that was done in LaTeX, and if you've ever worked with LaTeX tables, they are a little bit hard to work with, not exactly WYSIWYG, so I imagine they just made a mistake. It happens. All right. So we read all that, blah, 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 blah. The gain of MTDNN is also attributed to its flexible modeling framework, which allows us to incorporate the task-specific model structures and training methods, which have been developed in a single task setting, effectively leveraging the existing body of research. Interesting. So their sort of big claim at this point is that multitask learning is better because it allows you... Okay, so they haven't claimed this, but the question that I have is the big result that we've seen with deep learning models in general, in NLP and images, in, whatever you're working with, is the more data you have, the better they do, especially for complex tasks. And I'm wondering here if the benefit of multitask learning isn't just that you can use data from more different sources, which means that you have more total labeled data to train your model with, and that the benefit is actually not due to the architecture, but due to the fact that the architecture lets you have access to more total data for training. We'll see if they talk about that. So they're saying that it's because it's flexible, and you can use more model structures and training methods, and make use of more of the research. It's me says, does building NLP projects have the same procedure to follow in every NLP project, starting from cleaning data to building the model, just with different techniques at every step, or it changes with project? I'm a bit confused with so much new techniques to work with, like BERT and attention or word embedding. Yeah, so the cleaning that you do will depend on the specific model that you're using. So BERT and this model use, for example, a specific tokenizer. And if you used a different tokenizer, BERT wouldn't be able to work with your specific data set. But usually the general process is pre-processing, splitting your data into training and test, or test and dev, or whatever you're doing, and then training your model. And then if you're doing model comparison, training models with, different parameters, if you're doing hyperparameter search or something like that, and then comparing them. It's sort of the general flow. But yeah, what specific pre-processing you do will depend on the model that you're working with. And your language. So a big task in a lot of Asian languages is actually word segmentation. So you get the text in, but it's not clear where the boundaries are, because languages like Thai and Chinese don't use spaces between words. So yeah, it'll depend. The Answer Live says, I'm super disappointed that the top of Gloop model leaderboard is an ensemble model. That's just cheating. I mean... and it's me says, does pre-processing also have different techniques? Yeah, I could do a whole video just on NLP pre-processing techniques. And that was actually one of my research areas in grad school, showing that a lot of the information that is commonly removed during pre-processing is actually a sociolinguistic variable. So it's you're removing social information that people put into their text during pre-processing. And I have some papers on that. But I don't want to get too off topic, so we can make good progress on this paper. Okay, 1 sec, I'm gonna sniff. Sorry. Okay, 2 such examples use the SAN answer module for the pairwise text classification output module, and the pairwise ranking loss for the QNLI task, which by design is a binary classification problem in GLUE. To investigate the relative contributions of the above 2 modeling design choices, we implement different versions of the MTDNNs and compare their performance on the development set. The results are shown in Table 3. So the claim that they're making here is that the first author's method that they've been working on for a while is really beneficial, and that's why multitask learning is so good, is because it lets them use this method that the first author's been working on. And I'm not saying that they're wrong, but I get I'm picking up what they're putting down here. I'm following their line of logic. There's an ongoing discussion on revising the QNLI dataset. We will update the results when the new dataset is available. Where to get these and how to choose? I would always recommend, and you don't need a physical copy, it is available for free online, Speech and Language Processing by Jarafsky and Martin. And this is Is this the first edition? This might be the first edition. They're on the 3rd edition now. It's available for free online, and I would recommend it, and they go into quite a bit of detail. All right, BERT base. This is the base BERT model released by the authors, which we used as a baseline. We fine-tuned the model for each task. MTDNN is the proposed model described in section 3. We already read that. We then fine-tune the model using MTL on all glue tasks. Comparing MTDNN versus BERT base, we see that the results on dev sets are consistent with glue test results on table 2. So they're basically using the dev set as the second testing set, even though I think they trained on the dev set, so maybe a little bit questionable. Wouldn't necessarily recommend that as your standard operating procedure. STDNN stands for Single Task DNN, uses the same model architecture as MTDNN, but instead of fine-tuning one model for all tasks using MTL, we create multiple STDNNs, one for each task, using only its in-domain data for fine-tuning. Thus, for pairwise text classification tasks, the only difference between their STDNNs and BERT models is the design of the task-specific output module. The results show that on 3 out of 4 tasks, STDNNs outperform their BERT counterparts, justifying the effectiveness of the SAN answer module. We also compare the results of STDNN and BERT on QNLI. While STDNN is fine-tuned using the pairwise ranking loss, BERT views QNLI as binary classification and is fine-tuned using cross-entropy loss. STDNN significantly outperforms BERT. That it outperforms BERT demonstrates clearly the importance of problem formulation. Okay, so this is where they're saying, remember the one thing, and I was like, why is this a ranking problem? That seems weird. It means you assume that the correct answer is always in the data set. Here they're showing that the performance is much better from QNLI. Oh yeah, that is a big jump. So having it as a binary classification task is 88.4%. BERT is at 88.4%, and just changing it to a ranking task raises the accuracy to 94.6%, which is that's a very substantial improvement. But again, makes very strong presuppositions about the data that maybe in a research data set are going to be true, but not necessarily in the wild. AJ says, it looks like STDNN answers whether the gains are only from more data. Not necessarily. Well, okay, so they're suggesting that their problem formulations are better on most of the tasks, so that's good. But the difference between the STDNN and the MTDNN is the existence of more data updating the model overall. Actually, I don't know what your... I'm not disagreeing with you. Let me put it that way. I'm not disagreeing with you. So it does look like just having access to more data in the multitask setting does seem to improve the score. What I would be really interested to see would be multitask learning versus single task learning, where the total amount of data per training is the same. So in the single task learning, if I have 100 examples, and in the multitask learning, if I have 5 classes, I only get 20 examples per task, right? And then if we have like a head-to-head example where they have the same number of training examples for each of the tasks in multitask learning, and also the same number as they do for the single task learning, that I think would be a more fair comparison. And that would say to me that yes, it's not just the more data, it's actually the model architecture that's improving it. But they didn't do that. All right, well, they haven't done that yet. They might do it going forward. SNLI and Scytale results. So these are both natural language inference corpuses, which is probably why natural language understanding is in the title, because inference is an understanding task. In Table 4, we compare our adapted model using all in-domain training samples against several strong baselines, including the best results reported in the leaderboards. We see that MTDNN generates new state-of-the-art results on both datasets, pushing the benchmark to 91.1% on SNLI, 1% absolute improvement, and 94.1% on Scytale, 5.8% absolute improvement. I think Scytale might be a slightly less popular task, so if fewer people have done it, it seems like it would be easier to get a much better result, respectively. All right, so here's Table 4, and oh look, their model is better. I mean, this is just like your standard machine learning paper results table. And then they have the original GPT paper, but not the GPT-2 paper. which I believe also looked at Scytale. I don't remember. We read it and it sort of like went in one ear and out the other. I kind of remember it. Scytale maintained by AI2. Maybe it is Scytale that I remember hearing about. That might have been during the development of the data set. Okay. Domain adaptation results. One of the most important criteria for building practical systems is fast adaptation to new tasks and domains. This is because it is prohibitively expensive to collect labeled training data for new domains or tasks. I mean, that is like the whole field of linguistics is that, my dude. Very often, we only have very small training data or even no training data. To evaluate the models using the above criterion, we perform domain adaptation experiments on 2 NLI tasks, SNLI and Scytale, using the following procedure. What's this? Oh, okay, so this is just showing that MTDNN did better than BERT given less of the training data. Oh, we're about to read about these results. Wah, wah, wah. Sorry, I shouldn't have read that yet. So their process is to fine-tune the model on 8 glue tasks, excluding WNLI. I'm not sure if that's because it's also a natural language inference corpus, or because they had bad results on it and didn't want to include it. 2, create for each new task, SNLI or Scytale, a task-specific model by adapting the trained MTDNN using task-specific training data. A new task, evaluate the model using task-specific test data. Create a new task. Okay, so they're fine-tuning on their tasks, so that's the same as before. And then they're creating a new task-specific model, and then adapting the model. So they're actually updating all the weights in the model for their new task, and then evaluating the model using task-specific test data. Rugonk says, can you please let me know how to handle bias in NLP? There's a lot of different methods. I would point you towards the ethics in NLP workshop, and also the NLP papers from the Fairness, Accountability, and Transparency in Machine Learning conference would be my suggestions. We denote the 2 task-specific models as MTDNN. For comparison, we also perform the same adaptation procedure to the pre-trained BERT model, creating 2 task-specific BERT models for SNLI and Scytale, respectively, denoted as BERT. We split the training data of SNLI and Scytale and randomly sample 0.1%, 1%, 10%, and 100% of its training data. As a result, we obtain 4 sets of training data for Scytale, which includes 23, 235, 2.3K, and 23.5K training examples. Similarly, we obtain 4 sets of training data for SNLI, which includes 548, 5.5K, 54.9K, and 549.3K training samples. So they're sort of like seeing more and more of the training data. And I don't know if it's the same model or if they're actually training 4 models. Results on different amounts of training data of SNLI and Scytale are reported in Figure 2 and Table 5. We observe that our model pre-trained on GLUE via multitask learning outplays the BERT baseline consistently. The fewer training data used, the larger improvement MTDNN demonstrates over BERT. For example, with only 0.1%, 23 samples of the SNLI training data, MTDNN achieves 82.1% in accuracy, while BERT's accuracy is 52.5%. With 1% of the training data, the accuracy of our model is 85.2%, and BERT is 78.1%. We observe similar results in Scytale. The results indicate that the representations learned by MTDNN are more effective for domain adaptation than that of BERT. Interesting. So they're suggesting that, so BERT is, if we remember, a model that is only doing language modeling. So it's basically trained on a fill-in-the-blank sentence paradigm. And then it is, there's a layer on top of it that's your adaptation, your task-specific adaptation. MTDNN starts with BERT and then updates it based on a variety of different tasks. And I really want to quickly check Okay, so they didn't do WNLI, but they did do other natural language inference tasks in their fine-tuning. So at this point, BERT has never been asked to do natural language inference, and it's sort of adapting over time. And the multitask model has been asked to do natural language inference and has been updated with those weights. It's also been asked to do a bunch of other stuff. So it's already been tuned to natural language inference, and their argument, so they're saying the results indicate that the representation learned by MTDNN are more effective for domain adaptation than that of BERT. But it's already kind of been adapted to the natural language inference domain, right? Like, we've already trained this model to do natural language inference. It's already, had weights updated based on its performance on that specific task. So I'm wondering if these results aren't necessarily just because it's more flexible, but because it's already been trained on this particular task. And if it was given a completely different task, so something that wasn't entailment, that wasn't a task or related to a task in the original GLUE dataset, if it would do as well as fast. Right? So, sorry, I should have warned you. I'm trying to think of a good example. So it's done sentiment analysis. Do they do entity extraction? Yeah. So I don't think they did any sort of entity extraction or labeling. So if they really wanted to see if it was more flexible, I would compare the performance on something that was a task that had never been given to the multitask learning model before, right? I think this is not a surprising result given the tasks that BERT and MTDNN have been trained on specifically. I don't know that this is 100% fair. I think it's a good intuitive result. I don't think that they're, trying to trick us or anything. But I'm also not 100% sure that this shows that the multitask model is just more adaptable in general, or if it's more adaptable to the type of tasks it's already been trained on, if that makes sense, because it's seen more data and it's been updated using those data sets. Conclusion. In this work, we proposed a model called MTDNN to combine multitask and language model pre-training for language representation learning. The answer says, wait, hold on. I'm so confused as to why BERT can't do machine translation. BERT is just an encoder. Am I right about that? I know that the original transformer model had an encoder and a decoder. I think that BERT just isn't set up for sequence-to-sequence translation. The answer live says, can MTDNN do MT? Not as is, because I believe they also only have an encoder. Decoder. That's not how you spell it. Yeah, there's no decoder in their model. So basically the encoder takes the input language and changes it into numbers, and then the decoder takes those numbers and puts them into the new language. BERT has an encoder, so it takes the encoder from the Vaswani et al. Attention is all you need paper, but it doesn't have a decoder. So you could take BERT, use it as an encoder, and then create another decoder, so you could put it together with the Vaswani decoder. But if you don't have both parts, you get numbers out. You have to have some way to take those numbers and put them into a different language, if that makes sense. Yeah, you could absolutely insert a decoder. You could. I'm not especially interested in that. That seems hard and time consuming. But yeah, you could. Okay. In this work, we propose a model called MTDNN to combine multitask learning and language model pre-training for language representation learning. MTDNN obtains new state-of-the-art results on 10 NLU tasks across 3 popular benchmarks, SNLI, Scytale, and GLUE. MTDNN also demonstrates an exceptional generalization capability in domain adaptation experiments. It can adapt to domains it's already adapted to real well, which is good. You want your model to be able to do that, but I'm not sure that they've convinced me that this is a super generalizable model. There are many future areas to explore to improve MTDNN, including a deeper understanding of model structure sharing in MTL, a more effective training method that leverages relatedness among multiple tasks, and ways of incorporating the linguistic structure of text in a more explicit and controllable manner. Acknowledgements: we would like to thank Jade Huang from Microsoft for her generous help on this work. She's not an author, though? I guess she didn't help that much? Little sip. It's Me says, Speech and Language Processing is really a great book to get knowledge of NLP, but how to convert theory of this into code to apply in a project. And there's no appendices. I thought there might be an appendices. Yeah, that is a good question. They do have exercises in the book that might be helpful. There's also a lot of NLP coursework that's available online. I'm pretty sure there's a lot of Stanford coursework. There's probably some MIT coursework. So if you were looking for like a specific assignment, that might be a helpful thing. And there's also a lot of examples on Kaggle, and I find it very helpful to sort of like read through other people's work and figure out what they said and what they were doing. Okay, so thoughts on this paper. I think I like the general idea. I like the idea of starting with a pre-trained model and then updating it based on multiple different tasks. I agree that in principle, this should create something that is in general more generalizable because it's seen more different things. I think that it's possible that the gains that this model is seeing is because it is getting more data overall, and it's having more sort of like passes over more diverse data. And BERT is trained, of course, on a very, very large data set to begin with. So sort of like the proportional increase isn't huge. But I think to be really fair and figure out whether multitask learning really is better than single task learning, I would try and use the same amount of data for both tasks. So a lot of data for one task or little data for a lot of tasks, and see which one is more beneficial, because that feels a little bit more controlled to me. And then also to look at how well it generalizes, I would try to give it a task, maybe even that has a sort of a, so here we have the different classes of tasks. I might even try to give it a class of task it hasn't seen previously, and also a type of, excuse me, oh my goodness, pardon. So I would try to give it a task unlike ones that has been asked to do before. And I think for me, that would be much more convincing in showing that it is, a very, I'll get rid of this, sorry. I think for me, that would be more convincing in showing that it's a very generalizable model. Yeah, that's where I've come down on this. I think it's a perfectly good paper. I don't know that it's been published anywhere. Let's check real quick. Oh, used to be able to just highlight and then click the Scholar button and it would search it automatically. Copy, paste. Let's see, all two versions. So archive and archive. So I would probably want to see this paper actually published somewhere and go through peer review before I don't know. I really believe in the peer review process in my heart of hearts. And I would like to see this go through peer review before I'd be willing to like fold it into my own work, but that's my own standard of evidence. AJ says, how would you measure the same amount of data in gigabytes? The diversity of the data set matters too, right? Yeah, that's a really good point. I would probably measure the amount of data by the number of training examples. So like straight up just the number. And obviously for some types of tasks, you need more data than others. So for like co-reference, you usually need like a big old span of task. And for sentiment analysis, you need like a sentence. So that would be my personal way that I would measure it. I think it's interesting though. I think it's a good good example of multitask learning. I think the last paper I read on multitask learning was one on caption generation. I think it was one of the ACL best papers in like 2016, 2017 on actually it might have been EMNLP. Anyway, it was one of the best papers, and they were looking at the same time learning how to label frames, I think, of a video, and then also generate captions. So it was an image labeling and also a caption generation task, and then they saw like really big improvements because they could leverage insights from one and the other. Insights from one task and the other task. I say insights like the model like is actually studying and developing ideas of structure, and that ain't the case. All right, we have about 15 minutes, so I'm actually going to chase down what that AX is because it is bothering me. Let's see. I know they had a link to the glue benchmark, and I am too lazy. Where is it? Where's the link? At this point, there we go. It would have been faster just to search for it. All right, so MSRAI. Okay, so they actually still have, I don't know why I was bad at reading, but it looks like they actually are still at the top of the leaderboard, so maybe they've made some additional changes. And this is their GitHub repo. Yeah, okay, so it's the same paper, and they are at the top of the leaderboard. Okay, that's good to know. Nickerduke says Matthew's correlation coefficient. Yeah, I'm wondering, let's see what the original glue paper is. Paper, it's out of Stanford, right? It's me says, is there any book online? Not helpful. Glue benchmark. It's telling me how to do paper with glue. Benchmark. There we go. Is there any book online material which helped me with the knowledge of more code than theory in NLP? Don't think of me as a researcher. I really like the Spacey tutorials. They're much more focused on like, Spacey as a library is much more focused on putting things into production and being efficient and fast and iterating quickly. So I would look up the Spacey tutorials. I think it's spacey.io is the website. Don't quote me on that. Ines, INES, has a lot of really good stuff that she's put out, so I'd look for her stuff. So we've definitely, we saw that it was for binary classification, but I'm wondering what are the things that we are classifying binarily, you know? Oh, hey, this was out of UW as well. Cool. Omar, I don't think I know Julian. Maybe a grad student. Let's see. We were looking for AX, right? Softmax, max, inference max, descent. Necroduke says, yes, spacey.io. Never heard of it before. Oh, it's my favorite NLP library. For just like getting stuff done, it's really nice. I know, I stand for them a lot, but I really like it. It's very fast and lightweight. I like NLTK for trying stuff out. If you're like really want to like fiddle with all the knobs and like do a lot of adjustment and basically if you're a researcher, NLTK is pretty good. Core NLP, which is the Stanford library, is in Java, as I very embarrassingly discovered on stream a couple of months ago. So that's right on out. I feel like there's another couple ones that I'm just like completely blanking on. Anyway, I really like Spacey. That's the point of that GitHub. What was it? Matthew's correlation? All right. So it looks like corpus of linguistic acceptability. So remember, these are sort of like the weird sentences that linguists came up with, and we have people judge them. um, as an MLI. So they're using the Matthews correlation coefficient to see how well people do on, how well the system does on judging whether or not these are acceptable. But what's the task-wide one? Evaluation. And this one is for auditing, annotation, domains, NLI. Okay, so this is from the diagnostic data set. Since the class distribution in the diagnostic set is not uniform, and it is even less so within each category, we propose using R3, a three-class generalization of the Matthews correlation coefficient as the evaluation metric. This coefficient was introduced by Gorodkin 2004 as RK, a generalization of the Pearson correlation coefficient. Intended use. Oh, this looks like a specific task. Diagnostic data set, WNLI. Entailment. Used an LKK a few years ago on my thesis, but haven't since. It's still good. They're updating it. But it is, it's a little bit slower and it's a little bit more experimental, you know? Okay, so they're just saying that this is the metric that they use for some of the specific tasks, but what is the one that is for all of them? It's a gosh darn mystery. Skip that, GenSim, pre-training, benchmark results. For multitask baselines, we find that almost no model does significantly better on COLA or WNLI than performance from predicting majority class. Blah, 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 blah. They're talking about the different models that they've used, analysis, linguistic phenomena, domain shift and cues priority, conclusion. Okay, I still don't know what it is. Helpful. Nope. There we go. The answer life says too many math words, just 2 + 2 = 4. Quit maths, isn't it? Yes. Yeah, I have no idea what this measure is. So it is a measure that they are using. So they're using the Matthews correlation coefficient for many of these. Oh wait, so it's specifically diagnostics. So maybe that might help. Nope. Well, it's in my bookmarks now. Diagnostics. Diagnostics data set, a suite of diagnostic evaluation data aimed at giving model developers feedbacks on the type of linguistic phenomena their evaluated system handles well. Main tasks and the diagnostic data set. Okay. So it looks like they have an additional data set that they are evaluating against, which is a diagnostics data set that is designed to give developers feedback on their model. Is that what you guys are getting from this? Oh no, sorry. The geophysicist says, my email says live coding just now, and now I'm a bit lost getting into the paper halfway in. Sorry. Diagnostic data set. We include a small manually curated test set to allow for fine-grained analysis of system performance. Okay, so this is their performance on a smaller hand-annotated test set. So you do want it to be higher. Ooh, hachi-machi, that is not good. BERT plus single task adapters does not do super good on this this hand-labeled data set. Okay, so this is more for this is more for helping you evaluate your model and see what it's good for. It says, why doesn't she read the whole paper and figure out what it is? I think we've got it at this point. We can read the glue paper if we want, but I'm really interested in data set papers. I find that in general, other folks tend not to be as interested in data set papers because it just describes each of these tasks and how they are scored in detail. And it's more like a reference, right? It's like an encyclopedia. It's good to have, and you might need to look something up, but you probably don't want to sit down and read the encyclopedia. If folks really want a data set paper, I'm happy to read it. So the paper we just finished still has state of the art. Looks like they've made some updates. Their code is available. I think this is the GitHub link. Yeah, it is. So if you wanted to play around with it, you absolutely could. The Answer Life says the glove paper is a pretty fun read. What are we reading next time? I haven't decided yet. I will probably do another poll. So this paper was selected by a poll, which honestly, I was expecting the sparse vectors for sequence generation. Oh, is it? I don't think it was sparse vectors, actually. What was the sparse sequence generation? Was it sparse transformers, maybe? I haven't read the paper. Yeah. I was really expecting the sparse transformers paper to be the one you all picked, but you did not. And AJ says, I'd go over the super glue paper over the glue paper. Okay, that's a good recommendation. Yeah, so I'll put together a poll. Some folks have sent me different recommendations for papers over Twitter. You can send them to me via Kaggle, I guess. I might start a forum post and be like, hey, what do you guys want to read next? I'm open to things that aren't NLP papers. I warn you that I will not have as much background information if we do something in computer vision, but I will give it the old college try. A suggestion for sparse transformers. Yeah, again, I was really expecting it to win. So that was, nope, this isn't the paper we were reading. Let's go back to the paper we were reading just to look at it while we wrap up. So that was Multitask Deep Neural Networks for Natural Language Understanding, still currently top of the glue scoreboard, although it looks like they've made some tweaks since this was published, out of MSR, Microsoft Research. Interesting paper. I had some additional questions that I brought up, but I don't think it's bad work by any stretch of the imagination. Actually, I think work that makes you have questions is probably pretty good work. I will be back on Friday, and I'm thinking of switching my Friday live coding to the same time slot, so 9 a.m. Pacific, and I'll update you guys on that. There's a standing meeting I have that I have to try and move, and we will see if that happens. And if that happens, then I'll be at 9 on Friday, and if it's not, I will be at 4 p.m. Pacific on Friday, which is like 1 a.m. Indian Standard Time, which is not great for folks in India. So the Answer Life says, what's a sparse transformer? I don't know. I really want to find out. Presumably a transformer with like nodes removed? I don't know. It's a mystery to me. We got to read the paper. And thanks so much for joining me. I will see you on Friday, and I have a really exciting coffee chat that's going to be going up next Monday. I filmed it while we were all together with the Kaggle team, and we're talking about testing and data science, and I roped one of the Kaggle engineers into it to get like a little bit of an engineer's perspective as well as some data scientist's perspective. So I'm really looking forward to sharing that with you guys. And I will talk to you on Friday. Have a great day. Bye.